Let's start with multiplying with the same basis. That is, if you have a to the power of x times a to the power of y, what you'll do will be just to add the exponents and copy the base. So for x cubed times x squared, copying the base x and adding the exponents, it will be x to the power of 5. Keep in mind that when you add the exponents, that would only be true if we have the same basis. So if we have something like x to the power of 5 and y cubed, notice that we have different bases, that would be x and y, therefore we cannot add the exponents, and so the final answer will be just as is. Now for the next case wherein we have numerical coefficients r and s, we do the same algorithm of copying the base a and adding the exponents x and y, and we just have to multiply the numerical coefficients r and s. So when we multiply 3m to the power of 4 and 2m, we just have to copy the base m and add their exponents. We have 4 and 1, so that becomes 5, and we multiply the coefficients 3 and 2, having now 6. This time, if we have something like a to the power of x and we have to raise it to another exponent y, all we have to do is to copy the base a and multiply the exponents x and y. So for m cubed raised to the power of 4, that will be m to the power of 12. Notice that for the next example, we have different bases, so that would be m and n. If you have this, we just have to have the algorithm of multiplying the exponent z to the exponents inside the parenthesized terms. That's why we have there a to the power of xz times b to the power of yz. Applying that algorithm here, we now have m to the power of 10 times n to the power of 15. So for x times y to the power of 7 raised to the power of 3, that will be based from the same algorithm. Knowing that x has an exponent of 1, we now have x to the power of 3, y to the power of 21. Now for this case, all we have to do is subtract the exponent of the numerator by the exponent of the denominator. If you want to review the rules on subtracting integers, just click the icon there at the upper right corner of your screen and you will be redirected to the video about operations on integers. Now for this algorithm, yes, you just have to copy the base a, but you have there the subtraction of exponents. Be careful because it will always be subtracting of the exponent of the denominator from the exponent of the numerator, with the consideration, of course, that the denominator is not equal to 0. So for this example, x to the power of 14 divided by x to the power of 7, subtracting the exponent 7 from the exponent 14 will have x to the power of 7. So for the next example, that will be x to the power of 10 minus negative 2, which is equal to x to the power of 10 plus 2. So again, if you're confused on how come we have this, just click the icon there at the upper right corner of your screen and you will be redirected to that video about operations on integers. As for the next case, that will be combinations of the previous algorithms. That is, if you have a to the power of x over b to the power of y, but to be raised to the power of z, all we have to do would be multiplying the corresponding exponents. That's why we have there a to the power of xz all over b to the power of yz. So for x squared over y cubed, we'll now have x to the power of 10 over y to the power of 15. So for the next example, applying the algorithms that we have discussed, that would be now about distributing the square there. So that would now become 2 square, x to the power of 10 because we multiply the exponents 5 and 2, and denominator would be 3 square z square. There, we have a 4 because we square the 2, and we have a 9 for the denominator because we have the square of 3. As for the last law, which is about negative exponent will just be about the reciprocal of the base, assuming of course that the base is not equal to 0. So when x over y is raised to the power of negative 1, the reciprocal of x over y will just be y over x. Aside from having the reciprocal of the base in that algorithm, negative exponent would mean that to make the exponent positive, all we have to do is to have the reciprocal of the base. So for this example, this will now be n cubed over m squared to the power of positive 4. It will now be positive 4 because we had the reciprocal of the base. Just like that example x over y that was being raised to negative 1, after the reciprocal, their exponent will be a positive 1. So to simplify n cubed over m squared being raised to 4, we just have to use this algorithm. An alternative to this would be using this algorithm. So we just have to distribute the negative 4, so that would be m to the power of negative 8 and n to the power of negative 12. Having now negative exponent, we just have to use this algorithm. That is, to make a negative exponent positive, we just have to have the reciprocal of the base. So the denominator n to the power of negative 12 this time, to make the negative 12 positive, we'll have to bring them up. So we'll have them as a numerator. Hence, the numerator m to the power of negative 8 will now be a denominator with a positive exponent. To make this alternative method clear, let's have this example. Since that quantity is to be raised to a negative exponent, we'll have to have the reciprocal of the base. And the exponent negative 5 this time would be a positive. And distributing that exponent 5, we'll now have this. Notice that we have negative exponents here. So to make them positive, we'll have their reciprocal. That is, a denominator a to the power of negative 15 will now be a numerator with a positive exponent 15. And the numerator d to the power of negative 10 will now be a denominator with a positive exponent. We also have a law of exponents that says that whatever we raise to an exponent 0 will always be equal to 1.